Welcome back, everybody. Today is Wednesday, March 31st. Today we're going to start with this review question where you're going to look at the K-map and the don't care conditions and write the simplified logic expression Y. Go ahead and try that out. You guys have 2 minutes starting now. I'm going to give you guys another minute. About 30 seconds left. Good, I see more students join the Pear Deck. Okay. So I don't know what happened, but okay, so one person got it right. It was the first answer, so good job. I don't know what happened. My first period, everybody got this right, and then you guys, it looks like almost everyone got it wrong. I just want to remind you, so I tried to trick you so that, because I believe if you make a mistake in class, it's better because you're not going to make that mistake again. You'll always remember it. That's how I learn at least. Like once I do something wrong, I like never do it again. So I did try to trick you guys. There's 4 corners in this one. So that purple group right here. So a lot of you missed that. You've got the blue group correct, but I think you might have grouped the top and the bottom together or grouped them separately when you could have made a group of 4. So that group of 4 has not S and not U in common. And then this blue group right here would be T times not U. So always look out for those 4 corners. Again, if you got it wrong, you'll never miss it again, so I'm not too worried about it. But does anybody have any questions on that one? Okay. So just some brief announcements before we get started. There's no school on Friday. You guys know that. So also keep in mind, next week is STAR testing for English 1 and English 2. I know you guys are juniors and seniors, but it will affect you because your teachers are going to be proctoring the exam. So as of right now, so Wednesday at 10 a.m., I haven't gotten any information about when I'm going to be proctoring next week. So I might be in class Monday or I might be proctoring an exam. So you need to make sure that you check in with your teachers or check the hub to look for plans. If you start the live session on Monday, I'll try to give you some sort of notice, but we can always get pulled into a test like last minute. So check the hub, and if you go to the live session and I don't show up, you go on the hub, there'll be a survey for you to take attendance, and in the lesson I'll have a recording posted that you'll watch. So hopefully I'll be in class Monday, but you never know. I haven't gotten the schedule yet, and all your teachers will be affected, so make sure that you just check. If you don't have a live session, it doesn't mean that you don't have class. Your teachers might have posted something on the hub, so make sure you pay attention. In regards to STAR testing, if you're a junior and you have to take your AP US history exam this year, they're going to send out a survey in like April and ask you if you're taking it in person or not. So just look out for that. But as of now, we're just learning about English and English. Does anyone have any questions on that one before we get started? Okay. So I'll do my best to let you guys know if I'm in class Monday or not, but I don't know yet. So today we're going to log into the hub and we're going to open up activity 2.2.2, Universal Gates NAND. And you also can log into Multisim and get that started. So if you go on the hub week 8, day 15, you're going to download this right here, 2.2.2 Universal Gates NAND. And then if you want, you can open up Multisim and start a new circuit because I know that takes time sometimes. And you might want to get a mouse out if you use a mouse, if you have one. So I'll go over the activity with you guys first. We're going to do the first problem together today, and then you'll do the second one on your own. So I'll go ahead and read the introduction for you guys. The block diagram shown below represents a voting booth monitoring system. For privacy reasons, a voting booth can only be used if the booth is on either side is unoccupied. The monitoring system has 4 inputs and 2 outputs. So whenever a voting booth is occupied, the corresponding input, A, B, C, and D, is a 1. The first output booth is a 1 whenever a voting booth is available. The second output alarm is a 1 whenever the privacy rule is violated. So not in Texas, but in some states, they have rules at polling locations where if somebody's in the booth, you can't go to the booth next to them. There has to be at least 1 booth between each person. So we're going to pretend we live somewhere where this is a rule, and we're going to design a monitoring system with 2 outputs. So there'll be an output booth, could be like a light, and then the second output is alarm. So in this activity, we're going to implement NAND-only combinational logic circuits for the 2 outputs, booth and alarm. These NAND-only designs will be compared with the original AOI implementations in terms of efficiency and gate or IC utilization. In a future activity, these NAND-only designs will be compared using NOR gates. So we're going to do that next week. You can probably guess NOR will be not OR. So we're learning NAND this week, and then next week we're going to do this with NOR. So for this activity, the truth table is already written for you guys. We're just going to worry about making the K-map today and the circuits. So we don't have to go through and figure out all the outputs. So procedure, determine the SOP logic expression for the 2 functions below, booth and alarm. You're going to complete the K-map and show your K-mapping groupings below. You can use the shapes to make your groupings, or you can go to insert shape and select no fill. Write the SOP logic expression of the boxes at the bottom of the page. So I made the K-map for you guys. There's all these shapes that you can use to make groupings, or you can go to insert shape. And so like if I wanted to add a rectangle, I could draw a rectangle or square. But you want to go to shape fill, no fill, so that it's transparent. So you can add your own groups, but I just included 3 for you, which should be enough. And you can copy these and paste them for the second K-map below it. So you can see that on the right-hand side of this truth table, there's 2 outputs. You've got booth and alarm. So instead of having to write 2 truth tables, we're just going to write both outputs on the same truth table. So the first column, booth, is blue, and it's going to correspond with the blue K-map. And then the second column on the right is alarm. It's green, and it's going to correspond with the green K-map on the bottom. And then you're going to write the logic expressions on the bottom in the blue and the green. You guys know I love to color code. All right, so I'm going to fill out the K-map with you guys first. So I like to focus on 4 at a time. I'm going to look at booth, and I'm going to write these first 4 outputs, 1, 1, 1, X. So in my truth table, I'm going to start in the first row, and I'm going to go 1, 1, and then remember we're going to jump to the 4th row, 1, and then the 3rd row, X. Okay, so 1, 1, 4th row, 3rd row. And I got that from these first 4 columns here. I'm just going to bold them to mark them that I did it. Let me pause for about 45 seconds and let you guys do that on yours. So on your Word document, you're just going to put these 1s and X's. About 10 more seconds, and I'll move on to the next one. Does anyone have any questions? Okay. Now I'm going to move on to the second group of 4. So I've got 1, 0, X, X. I'm going to go on my second row, and I'm going to go 1, 0, X. And the last one is in the 3rd column, X, X. I'm going to mark it on my truth table so I know I did it. So let me pause for 30 seconds and let you guys do that on yours. Move on in about 10 seconds. Okay. The next 4 numbers I have are 1, 0, 0, X. And remember, you do first row, second row. So this one's going to go on the 4th row. 1, 0, and then we skip to the 4th column, and then the 3rd column. Okay, so 1, 0, 0, X. And then I'll do the last one, and then I'll pause and let you finish it. The last one is just X, 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 X. So that'll go in the 3rd row. Right here. Ooh. So I'll pause for about a minute and let you guys finish that up and just call out if you have any questions. You guys know 2.2. Under week 8. You're going to download the Word document, and I'll do this. Give you about 10 more seconds. Okay. So now I'm going to do the K-mapping grouping. So I'll do the first one with you guys, and then the second one you'll do on your own. So it looks here that I have 1, 2, 3, 4, 5 ones. And this one's pretty easy. You can see most of the ones are concentrated on the left edge and the top edge. So I'm going to take this shape. So this should be saved on yours, and you're going to drag it over, and you can make your first grouping. You can adjust the shape. So right here in my yellow group, and then I'm going to do another shape, and I'm gonna add these 4 together. And then all of my 1s are covered, so I don't need to make any additional shapes. I'm gonna move this square out of the way so it doesn't look like it's part of my K-map. And so your K-map should just look like that. And then I'll pause for a minute and let you guys do that. I know it takes a while on Word. So go ahead and make your groupings. And if you need to, you can go to Insert Shape. I don't know why it won't let me. Insert Shape. And you can make your own shapes. Just make sure that you go to Shape Fill, No Fill, so that it's transparent and it doesn't block what's underneath. And I'll send a screenshot in the chat in case you get lost or behind or your internet's slow. About 10 seconds, we'll move on. Any questions? Okay, so the next step is we're going to write the equation. So I'm going to start with my yellow group, and you can see the yellow group A and B change, but it's always not C, not D. And then for the red group, it looks like it's not A, not B. So I'm going to go ahead and write my equation, and you want to write it on the bottom. Simplified SOP equation. Not A, not B, plus not C, not D. Okay. Now, when you guys, so today and then on Monday, you guys are going to do the circuit alarm. So alarm, you're going to make a new K-map in the green space, and then you're going to write the equation for that K-map here. Let me pause for 30 seconds, let you guys write that logic expression. Booth equals not A, not B, plus not C, not D. Okay. Now we're going to go ahead and open up Multisim, and we're going to create the circuit. So you can see it says using Multisim, we're going to create an AOI circuit for the 2 logic expressions, booth and alarm. Limit this implementation to only 2 input AND gates, 2 input OR gates, and inverters. So some of you on the last assignment didn't follow directions. I only want 2 input AND gates. If you use a 3 input AND gate, you're going to get points off because it says it in the directions. And you're going to use 4 SPDT switches for A, B, C, and D, and a probe for the output. Take a screenshot of each circuit and paste them in the corresponding boxes below. So we're going to do booth together, and then you'll do alarm on your own. So go ahead and open up Multisim if you haven't already. Let me get mine out. And you guys can change the circuit name to 2.2.2 NAND, and I'm just going to add period. Then you can click on your workspace and go to the bottom where it says sheet settings. You want to make your width 200, your height 200, and then we can save this as public. So save it as public, okay? So that if you are having problems with your circuit, I can show you how to share it with me, and then I can actually like view it and modify it on my end. I'm going to pause for a minute and let you guys get that out. So again, you're logging into Multisim, renaming the circuit 2.2.2 NAND, and then changing the sheet settings on the bottom right to 200 by 200. Give you about 10 more seconds and we're going to move on. Okay. So I'm going to go through this pretty quickly and then you can finish it up during flex today. We're going to work on this today and Monday, so don't freak out. You'll have plenty of time. I just want to make sure that I'm not, taking too much of your flex time up. I will move pretty quickly, but I'll send you a screenshot of the circuit so you can make it yourself during flex. So don't stress out if you miss anything. What I'm going to do is I'm going to start like we normally do. So we need 4 inputs, A, B, C, and D. They're going to be switches. I'm going to use on the bottom, I'm going to go to digital constant, and use that as my power. And then we're going to go to schematic connector ground and use that as my ground. And then I'm going to grab 4 switches. So I'm going to go to switches, SPDT, and we're going to rotate it like so. And we need 4 of those. I'm going to copy and paste that 3 times. And then also want you to click on each switch and name them. So you just click on the first one, and under ID, you're going to change it to A. Second one will be B. Third one is C. And the fourth one is D. I'm going to put the left side is going to connect to ground as usual. And I know I'm doing this pretty quickly. And then the right side is going to connect to power for all 4. And then make sure I would go and save after each step, because sometimes you lose internet and things freeze up and you don't want to lose your work. So I know I just went through a lot at once, so I'm going to pause for about 2 minutes and let you guys do that on your end, and I'll repeat what I did. So you're going to go to digital on the bottom, constant, so digital constant. And then you're going to go to schematic connector, ground, and then switches, SPDT. You guys can use them, one of the classroom mics if you want to. Okay. And you're going to connect the left side of the switch to ground and the right side to power. And then name them A, B, C, and D. About 45 seconds left. Move on in about 10 seconds. All right. So now I'm going to do what we've been doing. So I'm going to zoom out, and I'm just going to make a wire that goes pretty much to the bottom of the page for each of these switches. And if you want, you can always make like a short wire. So you just click J as in Jaguar on your keyboard to make a junction. You can always make a short wire and then scroll down and just extend it if it's hard for you to get zoomed out enough to make a longer one. I'm just going to make 4 wires that go pretty much to the bottom of the page. And you can always make them longer later, but it's easier if you set it up correctly the first. All right, I'll pause for a minute and let you guys make yours. The switch is SPDT. I'll give you about 10 more seconds. And it's okay if you guys are behind. You'll have plenty of time during flex. All right, so if we look at our lab again, let's see what function we have to make. So our expression is going to be not A, not B, plus not C, not D. So I'm going to go into analysis and annotation, text annotation, and I'm going to write that expression out. Booth equals not A, not B, plus not C, not D. And then I'm going to go ahead and make that circuit. So I'm going to invert A and B first. I'm going to go down to the bottom where it says digital and go to, make sure you grab inverter and not buffer. Okay, inverter. So we're going to invert A, B, C, and D. So you can just copy this and make 4 of them. So again, that was digital inverter. And then A, B, C, and D. So let me pause for a minute and let you guys catch up. Please call out if you have any questions or put them in the chat. Again, don't be embarrassed if you're like 4 steps behind. I know it's really hard on the school laptops without a mouse using Multisim. Give you about 30 seconds. Move on in about 10 seconds. Okay. So just watch. I'm going to move pretty quickly, but I'll send you guys a screenshot of the circuit so you can catch up. Don't stress out. Next, I want to connect A and B, or not A, not B, with an AND gate. So I'll go to digital and we only want to use 2 input AND gates. So I'm going to have A, or not A, times not B. And then we want to copy that AND gate. Because we're going to have not C times not D. And then those are going to connect with an OR gate. So I'm going to go down to digital OR, 2 input OR. And then last thing is you're going to go to analysis and annotation, digital. place that on the workspace, and then remember to connect to the probe. You have to click J. And so that'll be your circuit. And I'll send a screenshot to you guys right now. And I'm going to save it. Okay. Now the next step in the lab is we're going to, so I'm going to skip down to, you're going to make the alarm AOI on your own. I'm going to skip down to number 2, and we're going to keep going with booth. So we're going to re-implement these circuits, assuming that only 2 input gates, or 2 input NAND gates, 74 less 00, are available. Using Multisim, we're going to create an AOI circuit for the 2 logic expressions and alarm. Actually, we're going to NAND circuit. Use the same switches and a probe, take a screenshot and paste them in the boxes. So if you guys remember from Friday when we learned about NAND logic, there are certain things we can substitute for AOI. So I'll just project this slide really quick because it's helpful. So anytime we have an AND gate, we're going to replace it with 2 NAND gates like this. Anytime we have an OR gate, we're going to replace it with 3 NAND gates, and then the inverter, we're going to replace with 1. So I'm going to start with the inverter because those are the first that we have. So basically in the circuit, whenever I have an inverter, I'm going to redraw it with the NAND gate. And the reason we made these wires go all the way to the bottom is I can make the next circuit right here and use the same inputs and not have to redraw those again. So I'll quickly show you what we're going to do. I'm going to go down to digital, NAND, to input NAND, and I'm going to redraw that circuit using only NAND gates. So this first inverter, I'm going to redraw using a NAND. It'll look something like that, right? So this is not A. And then I'm going to repeat that for B, C, and D. We're just making the inverter. Okay, so now I have not A, not B, not C, not D. Now we have to take these AND gates and replace those with NAND. So remember, for AND gates, we're going to replace it with 2 NAND gates like this. So then I'm going to go replace those. I'm just redrawing the circuit with NAND logic. And then the inverter. So you guys should be able to see right here, U5, that AND gate is now going to be 2 NAND gates. And then I'll repeat that for the second AND gate on the bottom. Just take a little while. And then the last gate, the OR gate, is the most complicated one. We have to replace that with 3 NAND gates like that, so 2 inverters, and then you join them together. And then we're going to join them together. And then the last thing is we'll have the probe as the output for digital. So I can just copy this one up here, paste it, and make sure you use J on your keyboard so you can connect it. And I'm going to click save. So this is before I make any eliminations. So we can look, I've got the AOI circuit on top, and then this is the NAND simplification or NAND substitution. So all the inverters are replaced with 1 NAND gate, all the AND gates are replaced with 2 NAND gates, and then this OR gate are replaced with 3 NAND gates. Some of you might already see it, but if we look at the NAND circuit on the bottom, around U13 and U16, you can see I have 2 inverters in a row. Same with the ones on the bottom, 15 and 17. So those are going to cancel each other out. If we invert something and then invert it again, it's just going to be canceled out. So I can press Control, click down on my mouse, and then draw a box over these 4 and just delete all 4 of them. And we don't have to move this over. We can just make the wire longer and connect our wires. And so this is our new circuit simplified for NAND. So I've got these inverted, and we use 1, 2, 3, 4, 5, 6, 7 NAND gates. And then on the top, we use 1, 2, 3, 4, 5, 6, 7 gates total, but they're all different. So I'm going to take a screenshot of this and send it to you guys. And you can see that you can make multiple circuits on the same setup. So see how I just made these go down? You can put the next 2 down here. You don't have to redraw it every time. All right, so for today, all I want you to do is get up to at least this point here. Let me save my work. So for today, all I want you to do is complete your K-map, your AOI, and your NAND circuit for boost, which is what we just did together. And then next class, we're going to finish the alarm, K-map, AOI, and NAND circuit for alarm. And it will be due for a major grade on Monday at 11:59 p.m. So you guys are free to finish it today. You can check your work with me, but at least I want you to get up to boost with the NAND circuit. So if you don't finish it today, that's fine. You'll have time on Monday. But yeah, that's it. So as usual, I'll be here the entire class period if you need help with anything or you want me to check your circuits or check your work before you hand it in. I encourage you to try to get it done today so you don't have to worry about it on Monday. Again, we don't know if I'll be here on Monday or if I'm going to be proctoring. So try to take advantage of the time while I'm here. And that's it for today. So does anyone have any questions before I let you guys go to Flex? All right. You guys are free to go. I'll stay back the entire period if you have any questions. Otherwise, I'll see you sometime next week. Bye, guys.